Go. Okay, we go. All right, now drop this. Is this going to go faster or slower or what? Slow? Oh, you've seen this one? Somebody else want to try it? Yeah, okay. All right. You want to try it with the marble first? You try the marble. Okay. Really fast. Okay, drop it. It takes about 5 times longer. So why is that? Well, a magnet that's moving by a conductor like copper induces a current to flow. The current generates a magnetic field pushing the opposite way. So it takes you got to use a really strong magnet. You got to use something that's a very good conductor like copper. And it can't be magnetic, otherwise you just trap it. Okay. Okay, let's compare the marble with the magnet. First, the marble. And now the magnet. I have a little color demo here. Where did I put that? Ah, yes. All right. So I have some clear solutions, and they are of it's a very weak solution of something called phenolphthalein. I don't know if it sounds familiar to anybody.
They used to kill people.
No, it's used in X-lax. But chemists use it as an indicator dye when they're balancing an acid against a base. So it's colorless. Now, we'll take some lye, sodium hydroxide, a weak solution. And, okay, a different participant. Anybody? You want to do it, Evan? Okay, here. What we'll do is we'll fill this up with a little bit of this solution. Okay, now we'll hold it out here. So you hold this over the solution and squeeze it. Squeeze it hard. Okay, that is the form of phenolphthalein molecule when it's in basic solution. So it basically changes the shape of the molecule. Oh, okay. We're done with it. But can we do that backwards? Well, okay. Yeah, this. Now this stuff is corrosive, but not very much. And when you've been a lifelong chemist, you get kind of casual about it. Let's see if this is the phenolphthalein. That was the phenolphthalein. I can tell, because if you get sodium hydroxide on your finger, it feels slippery, because it's doing the same thing to the oils in your skin that it does when you make soap. It breaks down the oils into fatty acids and glycerides, but it's kind of harmless. Okay, the way to reverse this is with acid. So another person, Giovanni, how about you? Giovanni's a student at our school. Okay, so we're going to hold this up and why is it? It won't show on the black table. Okay. So let's hold it over here. And then squeeze it in there. Did we get enough? Okay, good. Okay, take it out. Color's gone.
Wow.
So, in the form that it takes when there's acid in the medium, it's colorless. If it's basic in the medium, it takes that beautiful pink color. All right, in the center we have a solution of phenolphthalein, as I showed in the show. I don't want to make a mess. And all right, let's start with the sodium hydroxide. We'll drop some in. There we go. The classic color of phenolphthalein. Right. Now let's reverse that. Boy, these are hard. I'll use the same pipette. It's not a big deal. And voila, we have reversed it. Okay. Here's another thing with color. So this is a violet laser. Okay. Who has white clothing? Oh, Giovanni, you've got a white sleeve. Let's come up there. Okay. So, turn around so everybody can see you. All right. So now, if you look at it on my finger, it's sort of a dull violet. But look at on his clothing. So, see? What's going on there? Basically all white clothing that's sold now, as well as white paper, has what are called fluorescent brighteners. So they absorb violet light or ultraviolet light from the sky. The molecule drops a little bit in energy and it emits a whole range of light, basically white light. So what's that for? It's to make your clothes look like they're not turning yellow. It used to be that people used bluing. And I have some of that. And that's an interesting compound. It's ferrocyanide. Cyanide, yeah, it's got cyanide in it. And it's almost impossible to get the cyanide out. I'm very sensitive to cyanide. There's 8% of us people who are very sensitive to cyanide. So I could smell, I used to work in a chemistry building, and if somebody way at the end over there was using cyanide in the reaction, I could smell it. It doesn't smell like almonds to me. It's hard to describe, but most people can. Okay. So, another thing that we have, does anybody recognize what kind of a plant that is? It's a spice. Basil. Okay. Well, like all living plants, look at the color of the light when I shine the violet laser. Remember, it's violet. Okay. Now it's pink. Can you see that? So what's happening is the chlorophyll molecules naturally absorb blue and red. They leave the green unabsorbed, that's why the plant looks green. But when they absorb any light that's either blue or red, they create what's called an excited state of the molecule. But the higher excited state, when they absorb violet or blue, collapses down to the first one. That one can lose that energy as light. It fluoresces. It fluoresces red. So that's why it looks pink when I shine the light on it. On myself, let's see, where are we? There. And then on the whitened paper, you can see the great increase in fluorescence. And keep that on the way of, more light. Now these take a little bit of practice. Okay. I've got a bunch of these for anybody who wants to try it. About 6 of them. Okay. What you want to do is to look at a bright light through there, and off to the side you're going to see a spectrum, a range of colors.
Yeah, I got that thing.
What? You can share those. So look up at one of the lights in the ceiling. And then off to the side, usually to the left, you're going to see the colors of the rainbow spread out. So what that's doing is breaking up the white light into all the colors that go into making it up. You can even look out the window, probably. Get it right close to your eye.
Let's see. Okay.
Did you see it, or did you try it? Did it work? Good. It does? Okay. Yeah, it probably does look better at the window. It's got a really bright light. Okay, so you're probably not aware of it, but ordinary white light is made up of a whole range of colors of rainbow. And this is just a way to spread it out. The first person who made a good demonstration of that was Isaac Newton. He also showed that you could take all those colors and bring them back to make the white light again. You put it through a prism to spread it out, another prism to converge it, and you get the white light back.